This is the presentation of my final project of wireless communication, and the title of my final project is Channel Analysis and Estimation in OFDM System. Okay. I'm going to talk about my project in these 5 aspects. The first is Introduction of OFDM. The full name of OFDM is Orthogonal Frequency Division Multiplexing. It is a type of digital transmission and a method of encoding digital data on multiple carrier frequencies. And it has a lot of applications. I just list some of them. It's just a small amount of them. Like, it's widely used in some digital radio system and in module TV system and personal area network. But basically, OFDM is widely used in wireless circumstances. There are a lot of features of OFDM, and the most important one is orthogonality. All subcarriers are orthogonal to each other, such that not only does the mutual interference between subcarriers are reduced, but also spectrum utilization is improved as well. Also, there are a lot of advantages and disadvantages of OFDM. For advantages, OFDM can effectively reduce its bit error rate at the receiver. Also, the spectral efficiency is increased. It has good reliability when facing deep decline, and the transmission rate is really good. Also, there are some disadvantages, like the sender and receiver should be precisely synchronized, and OFDM is sensitive to Doppler effect frequency drift. Also, it has a high PARP, which is peak to average power ratio. And this is my diagram of my system. You can see that the upper system is sender, and the other part, the lower part of the picture is the receiver. The sender is going to convert sent digital signal to a mapping of subcarrier and use IDFT to transmit it from frequent expression to time domain expression. IFFT and IDFT has same function but better efficiency, such that it fit well with all systems. Receiver works the opposite by using IFFT. Subcarriers are converted to digital signals. And you can see modulation and demodulation module in my system. So in an OFDM signal contains multiple subcarriers, and each of them can receive modulation from PSK and QAM. OFDM sender maps signal bit stream to PSK or QAM sequences and converts series sequence into parallel sequence. OFDM symbol is composed signal of n parallel signal, so that if the transmission time of a single series signal is TS, then T system, everything is finished, should be n times TS. And the frequency of frequency domain modulation signal XK is FK is equals to K minus T system, system time, and the number of subcarriers n. Alright. And there are a lot of existing approaches for my project to estimate the channel. And no matter what approaches it is, it needs to follow 3 steps to design a channel estimator. The first is we should determine how to select and insert pilot information in sender. And after we finish this, we need to decide how to get the channel information from pilot in receiver. And there are a lot of different methods like LS, MMSE, etc. For this project, I'm using LS, which is least square. And the third step is how to recover all time information of subchannels according to the pilot. There are a lot of different kind of pilot for OFDM channel, and I'm going to talk about two in this presentation. The first is block type pilot. You can see that the picture on the left side of the screen. So in one OFDM symbol, all subcarriers insert into this pilot, and this type of pilot has good estimate performance on strong frequency select fading. There's another type of pilot which is COM type pilot. This kind of pilot can be inserted into some subcarriers at any time. This type of pilot has good estimate performance on strong time selective fading. And this is the result figures of my simulation program. For this page, the figure on the left side of the screen is the initial signal that goes into my system, and the second figure on the right side of my screen is the signal after multiple path channel, so it's out of my system. The parameters of my signal is I used 100 carriers, and the length of cycle prefix is 15. I used 8 PSK and QPSK in my system, and the beginning of my pilot interval is 4, and I'm going to change it. Well, you will see in the following pages. And I used 99 OFDM symbols. You can see after my multipath system, the signal changed a lot. So we need to estimate the channel. This is the channel that I used 8 PSK. The first picture of this page is the constellation. It's a constellation diagram of 8 PSK OFDM system. The second one is the error curve under ETUs 300 plus AWG in channel, and the pilot now is 4. In the third figure, everything is the same except my pilot interval is 2. So you can see both of them are in 8 PSK. The smaller the pilot interval, the better the performance. And now I change from 8 PSK to QPSK. Everything is the same except this phase shift keying. So the first picture is the diagram, and the second is the error curve when the pilot interval is 4, and this third is pilot interval is 2. Also, it is when the pilot interval is smaller, the performance is better. And by comparing this and the last page, we can see that QPSK has a better performance in OFDM system. So here are the conclusions I get from my experiment. First of all, 8 PSK and QPSK are efficient when paired with OFDM. There are a lot of other kind of phase shift keying, but in my project, I just use this two. And also, OFDM is very robust to noise and ISS and ISI. Well, but about the speed, we can't do more about it. And the larger the SNR, the smaller the gradient of BER dropping, bit error rate. And the smaller pivot interval, the better performance. And compares to 8PSK, QPSK's overall performance is better. Alright, so the last part is problem understudy. Actually, I don't understand. I don't know how to write. Because there are a lot of problems. I can't write it all down because it's a lot of small problems. So I just write four big problem, for how to say high level problem I faced. The first is those mathematical equations. Well, I was really insane because it's so hard. Well, but it's really hard to understand. And the second is, well, my major is CS. I am a little bit unfamiliar with signal processing and system simulation, but but doing this project is pretty fun. Also, it's hard to find a fitting. Sorry, it's not fitting. I should say a good pilot for my system because there are so many kinds of pilot. There are calm, there are discrete type pilot, there are block type pilot, and so on. But after reading a lot of web pages and other ones code, I think block pilot is it's the best for me. And the last thing is, when using MATLAB, there are so many things I need to pay attention to. Sorry, it's not we. I need to pay attention to. MATLAB, it's so powerful, and it's so hard. That's it. Thanks for listening.